previously you have been looking at determining the length of the hypotenuse, but now we're going to look at how you can determine the length of any of the legs of a right triangle using the Pythagorean theorem. So the first thing that you need to do is determine the hypotenuse. So in this case, we see the right angle. Across from the right angle is the hypotenuse. So we know the hypotenuse, that's C, is equal to 13. So next thing we need to do is we need to determine if we're going to be adding or subtracting. Way to know this is if we do not know the hypotenuse, we will add, and that's what you've been practicing. A squared plus B squared is equal to C squared, C being the hypotenuse. If you do know the hypotenuse, in this case we do, we will be subtracting. C squared minus B squared is equal to A squared. So the leg that we do not know is going to be A, and the leg that we do know that is not the hypotenuse is going to be B. So in this case, what we're going to be doing is we're going to be doing C squared minus B squared is equal to A squared. So C we know is 13, so we're just going to plug in our values here. We have 13 squared minus B, which is 5. 5 squared is equal to A squared. So we have 13 squared, which is 169, minus 5 squared, which is 25, and that difference is going to be equal to A squared. So we're going to find the difference, and that's our next step. So we have 169 minus 25, which is 144. 144 is equal to A squared. Now remember that we're looking for A, not A squared, so we need to do the opposite of square, which is the square root. That's going to cancel out that square there, and the square root of 144 is 12. So we know that that missing side length A is 12. Alright, let's try this again with another example. Here, first thing we need to do is we need to determine the hypotenuse. It is across from that 90-degree angle. So in this case, we do know the hypotenuse, that's C, is 5. So because we do know the hypotenuse, we are going to be subtracting. The leg we do not know is going to be A, and the leg that we do know that is not the hypotenuse is going to be B. We're going to write down C squared minus B squared is equal to A squared. And we're just going to plug in values here. C is 5, so we're just going to plug that in for 5. 5 squared minus B, which is 3. 3 squared. Oh, go away. Is equal to A squared. Okay, so now we're just going to do 5 squared, which is 25, minus 3 squared, which is 9, is equal to A squared. 25 minus 9 is 16, so we have 16 is equal to A squared. But remember, we're not looking for A squared, we are looking for A. And to do the opposite of square, that's going to be the square root. So 16, the square root of 16 is 4. That one was lovely. So we have 4 is equal to A. That means that the length of this leg is 4 units. All right, let's try another example here. We need to determine the hypotenuse. We have our 90-degree angle. Across from that 90-degree angle is the hypotenuse. In this case, we do not know what the hypotenuse is. So because we do not know, we're going to be adding. So we're going to give these legs values of A and B. And this one we should be familiar with. A squared plus B squared is equal to C squared. So now we're going to plug in the values of A and B. A is 15, so we're going to have 15 squared plus B, which is 8 squared. Oh my goodness, I hit that thing again. Is equal to C squared. 15 squared is 225 plus 8 squared, which is 64, is equal to C squared. So now we need to find the sum of 225 and 64, and that is 289. So we have 289 is equal to C squared. Now remember, we're finding C, not C squared, so we need the opposite of square, which is square root. And we get that C is going to be equal to 17. That means that the hypotenuse has a length of 17 units. All right, next here we have determined the hypotenuse. So we have this 90 degree. Across from the 90 degree is the hypotenuse. We do know it. That is C. That means that our unknown leg is going to be A, and our known leg that is not the hypotenuse is going to be B. And because we do know the hypotenuse, we're going to be subtracting. So we're going to plug in C squared minus B squared is equal to A squared. Now we're just going to plug in the values for C and B. We're going to have 29 squared minus 21 squared is equal to a squared. So now we're just going to find the squares of these. So 29 squared is 841 minus 21 squared, which is 441, and that's going to be equal to a squared. And then when we find the difference of 841 and 441, we get 400. 400 is equal to a squared. Now remember, we're not finding a squared, we're finding a, so we need to do the opposite of square, which is the square root. The square root of 400 is 20. So we get that A, our missing leg, has a length of 20. All right, and we have our final example here. First thing we need to do is determine the hypotenuse. We have the 90-degree angle. Across from the 90-degree angle is the hypotenuse. We do know the hypotenuse, that is C. The leg that we do not know, in this case, is going to be A, and the leg that we do know is going to be B. Because we do know the hypotenuse, we're going to be finding the difference. That means subtracting. So we're going to be doing C squared minus B squared is equal to A squared. Now we're going to plug in our values for C and B. C, which is our hypotenuse, is 20, so we're going to have 20 squared minus B, which is our other leg, 7 squared, is equal to A squared. So now we need to square those values. We have 20 squared, which is 400, minus 7 squared, which is 49, and that's going to be equal to A squared. So now we need to find the difference of 400 and 49. That means that we're subtracting. We get 351 is equal to A squared. This is not a perfect square, so this is where your reducing radicals comes into. And so we're going to do 351, and we're going to find the prime factorization. I know that because the digits 3, 5, and 1, 5, 6, 7, 8, 9, add up to 9, that is going to be divisible by 3. So 351 divided by 3 is equal to 117. Again, let's see, 3 is prime, so we stop there. 117, those digits 7, 8, 9 also add up to 9, so that's also going to be divisible by 3. And that's going to be 39. 39 is also divisible by 3. And it's going to get us 13. 13 is prime, not divisible by anything, so the prime factorization is going to be 3 cubed times 13. Remember, we can only take out something that is squared, so we could rewrite this as 3 squared times 3 times 13. So the square can come out. So that means that we get a 3 on the outside. On the inside, we have 3 times 13. Which gets us 39. So the value of A is going to be 3 root 39 in its most reduced form. And there you go.